Welcome to the 9th quarterly report detailing the progress made by NASA's ARES projects on America's next launch vehicle. Last quarter, the project reported on Marshall's historic dynamic test stand, dome gore panel fabrication, and J2X power pack testing. Work from last quarter continued wind tunnel analysis, J2X component testing, and fabrication of the first stage's demonstration Motor 1. A 4% scale model of the ARES 1 was tested this quarter to gain higher fidelity data about aeroacoustic environments experienced by the vehicle. This model is the largest so far tested by ARES and is equipped with a large number of tiny pressure transducers to measure force on the vehicle's surface. Wind tunnel testing also continued this quarter on the 1% scale model of ARES. This model, with full protuberances to accurately represent the final flight vehicle, was tested at speeds from Mach 1.6 to Mach 4.5. This model was previously tested at Boeing's Polysonic Wind Tunnel to cover speeds under Mach 1.6. ARES has now conducted over 7,000 hours of wind tunnel testing over the life of the project. The first stage team began mating components of the nozzle for demonstration Motor 1 this quarter. An inert compound was used to verify that the nozzle's structural performance would not be compromised. During this test fit, the sample bonding compound was kept sealed in plastic to prevent the bonding surface from being contaminated. This way, during the actual assembly, all adhesive bonds will form properly. A new liner system for the solid rocket motor is being tested for the ARES first stage. This new liner system eliminates asbestos in both the liner and the insulation used in the motor. It also provides a stronger system than existing materials. The new liner material is applied to the motor case using a spinning disc that rotates at over 10,000 RPMs, slinging the material to cover the inside of the case wall. ATK recently completed a successful test casting of the first stage forward segment. Using an inert material to simulate the solid rocket propellant, the team tested the new procedures and tools that will be used for ARES. The team also tested installation of inhibitors which prevent premature burning of the propellant during flight. This ensures that all of the propellant does not burn at once. Once the inert propellant is ready, a mixing bowl containing 600 gallons of the mixture is moved to a casting pit, where it is then poured into the motor segment around a casting mold. The forward segment of the ARES first stage uses a mold that has 12 fins to ensure the correct propellant geometry. Once the motor is cast, the core and fins are removed to reveal the final shape of the forward segment propellant. The new mold tooling allows for this procedure to occur remotely, increasing employee safety during operations with live propellant. Engineers used more than 20 microphones around the site of a recent solid rocket motor test firing to gather data about the liftoff acoustics of the ARES 1. By collecting this data, engineers can make better predictions of how the sound from liftoff will affect the surrounding area. These predictions will inform the design of a sound dampening system for the ARES 1 launch pad. This test motor, designated FVM2, was the oldest solid rocket motor ever fired. The motor was fabricated more than 7 years ago. Another motor manufactured at the same time was tested in 2005. This gives the team the opportunity to compare the effects of aging on solid rocket motors. Work continued on upper stage confidence panels this quarter. Bump forming is used to produce barrel panels for the upper stage's propellant tanks, aft skirt, and instrument unit. This technique uses a press to incrementally produce a curved panel from a piece of flat, stiffened metal. This panel was the first to be made using this process at Marshall since the days of the Saturn rockets. Upper stage engineers worked with a new software application called Delmia in conjunction with the full-scale interstage mock-up constructed at Marshall. This software allows designers to analyze how workers will interact with final flight hardware and account for these human factors in their early design. Using these tools leads to more cost-effective engineering and can be constantly updated to reflect the most current design. Upper stage engineers are also using this simulation tool to plan the manufacturing of the ARES 1 main propulsion test article. This test article will be critical in verifying the integrated upper stage interfaces and operations with test support equipment and ground operations. Having completed the PowerPack 1A test series, engineers removed the engine from test stand A1. This marked the conclusion of a year-long effort to refurbish the stand, install the engine, and run a series of both cold flow and hot fire tests. The next PowerPack series is scheduled to begin in 2010 and will use developmental J2X turbo machinery instead of heritage J2 hardware. Manufacturing of components for the J2X developmental engine hardware is currently underway. These parts are for the workhorse gas generator testing being conducted at Marshall. The testing underway at Marshall's Test Stand 116 is examining the temperature distribution of hot gas as it arrives at the engine turbine. Tests are being conducted at 2 different thrust levels, with 21 tests conducted through last quarter. The components from these tests will provide a proven workhorse gas generator test article for a future PowerPack test program. Join us again next quarter for further developments at Marshall's manufacturing test facility, first stage demonstration motor, and the next major ARES 1 milestone, the preliminary design review. If you'd like more information about ARES plans and progress, please visit us on the web at nasa.gov/ARES.